Every algorithm, no matter how complex, starts with the same fundamental requirement: a way to store and organize information. In Python, the basic units that hold your data are called variables. To see exactly how these work, we are going to write a functional Python script. Our goal is to build a user profile that correctly assigns and translates different types of data. Step 1 is to prepare your workspace. Open your preferred Python code editor. We will write our code on the left and check the results in the execution console on the right. By typing these commands yourself, you can see the immediate transition from a line of text to a functioning instruction in the computer's memory. Let's initialize our script. First, we need to assign a name and an age. Type name equals Anmol, and right below it, type age equals 20. When executed, Python creates a dedicated storage container labeled age, dropping the number 20 inside. Later, to perform a tabulation, Python opens this container and pulls that specific data right into the program's logic. You might notice we didn't tell Python that Anmol is text and 20 is a number. Python uses dynamic typing, meaning it detects the specific category of the data automatically as soon as the code runs. This means you can focus on the logic of your program rather than manually declaring every data category before you use it. As we expand this user profile, we have to stay within Python's specific naming conventions to prevent the script from crashing. Rule 1. Variable names contain letters, numbers, and underscores, but cannot begin with a number. Rule 2. Spaces aren't allowed. To separate words, use an underscore. Rule 3. You cannot use reserved Python keywords like if or else as names. Rule 4. Python is case-sensitive, so age in lowercase and age with a capital A are two completely different containers. Following these naming conventions consistently prevents the most common syntax errors that forcefully stop a program from running. Now let's complete the profile by adding two more variables, a decimal score and a student status indicator. In Python, numbers are split into two main types. Integers are whole numbers, like our age of 20. Floats are decimal numbers, like a score of 95.5. Text data is called a string. Whenever you assign a string, you must enclose the text in quotation marks. This identifies the content as literal text rather than a variable name or command. Finally, Booleans are binary switches that can only hold a value of true or false. These must always be capitalized for Python to recognize them as valid Boolean values. These four types, integer, float, string, and Boolean, represent the starting point for nearly every dataset we'll use. Because Python detects data types automatically, you may eventually need to verify how the language has categorized a specific variable. We can expose a variable's classification by nesting a type command inside a print command. Type print type age, and then print type name. Check the execution console. Python prints class int for the number and class string for the string. Now let's look at a common mistake. Add a new variable to your script. Type level equals 10, placing the number inside quotation marks. Because of the quotes, Python treats this as text. If you try to add a number to this level, the script will fail because you cannot perform math on a string. To fix this, we use type conversion. Type level equals int level. This tells Python to resave the text 10 as a whole number. Running our print command again confirms the shift to class int. The data is now ready for math. When you encounter errors in your mathematical logic, checking and converting your data types will be your primary diagnostic tool. You now have a script that successfully manages multiple data types while avoiding the most common syntax traps. These basic variables are the building blocks for the more complex structures we'll solve later. For example, an array is simply a collection of variables, and a linked list uses them to point from one piece of data to the next. Algorithms require this reliable storage to function. Without variables to hold on to state or intermediate steps, a program would have no way to track progress toward a solution. Now that we can store data, our next step is to make our programs interactive. In the next video, we'll learn how to accept external user inputs to update our variables in real time.